GM, welcome to a new episode of Protocol Explorer. Today we have two very, very mysterious icons who will not reveal themselves, but will be joining me to tell me about Avail. Naruto, if you can go first, give us a little intro to yourself. I know you're not the actual anime character, but tell us who you are.
Hey guys, I am Naruto. This is what I go with in Web3. I'm working as a DevRel at Avail, and I think I'm the latest hire here. And been enjoying all my work here. A lot of things that we do is basically uh, talking to integrations partner, explorations team, being that the person who actually work between multiple teams and also like looking at the events, hackathons, and all those things. So definitely very curious here to meet Rahat and then talk about Avail and what we do. QDK, go for it.
Hey everyone. I'm QVDK. I work as a senior R&D engineer at Avail. I've been here a while, almost running up to a year here. Happy to be working at Avail. If you know me, you probably know I build stuff like Avail Up, the ZK Validium. We also have some other new cool stuff coming out like Nexus and CDK Validiums in the near future. And of course, happy to be hosted by Rahat, one of our most long-time friends, at least DD, going back to DD times, been a while. So yeah, happy to be here, happy to join you all. Nice to be here.
Yeah, we go back. What is it to
3 years,
2 years?
three and a half
2 years,
years.
yeah.
Yeah.
Yeah, like Naruto came in the picture later. Like he's not as important as like me and you in our relationship, but
Yeah, we don't know him. Yeah, he's just there.
But I became the best friend. Just saying.
Who's? I don't know.
debatable, debatable.
uh, I'm sorry
Awesome.
about that.
So, Naruto, you mentioned a couple things about your job. I'm very curious. So, like, both of you are actually, I guess anonymous, pseudonymous, or however. How does that affect your day-to-day job? Obviously, you guys have very Naruto. At least you have like a very client-facing role. You talk with a lot of folks. How does that kind of affect you deciding to stay anon and like do like stuff like events and going to all these things? And I think QDK, you do some of that stuff too. Like you're a part-time KOL, so would love to hear from you
I wish I was a KOL, but
too.
I think Naruto is the real KOL. I'm not gonna lie.
Not at all. I think it's definitely a little bit tougher now because you're working at an actual big company. You're part of the organization. You need to talk to a lot of people, and a lot of them want to see your face or like just to have a real conversation. So it just I think before I started at Avail, I was never like keeping my camera on or like just talking to people directly and not going to too many events. Like the only event I actually go to is like Eat Denver. And then one time I went to Eat India. So just those. But now I think we have to somewhat show our faces, which is, I think, okay, people, respect the privacy. They don't take it out on Twitter. And I think that's what we both want. We just don't want our faces on Twitter. But QDK, yeah, you can also, put in your thoughts.
I've worked in companies as an anon. I've also worked in companies without being an anon. So kind of I've dealt with both. For me, it's not really a big deal. Like a lot of people kind of know me with my real face. I'm really fine with that. It's just like it's always been my GitHub username, right? So I sort of just it felt right to also be pseudonymous with that name. So that's sort of how it is for me. And I mean, crypto as a whole has always been very, how do I, pseudonym friendly, right? So it's like the right place to do things if that's how you want to be. And I mean, honestly, I'm lucky that crypto is the space that offers that. But yeah, I mean, it's always been nice. Like, at least with crypto, it's always been easy as well. That's what I love about the space so much.
Nice, nice, awesome. For folks tuning in, if you want to be displayed on the screen just like this, you can ask questions. You don't just have to say first, like some people here did. You can also say other things and ask questions along the way. But yeah, we can dive into things a little bit here. I have just a general question about Avail. Like, what exactly, first of all, is Avail? And what is this unification layer? Would love to understand and conceptualize that.
Um, so I think like I can start off and then Kyudeki can expand more because he's been here for way longer than me. But the basic
Not that.
idea, he's like the founding employee, just so like he's that founding
Okay.
employee who built the whole thing
Okay.
from
Oh, no, no, no.
Okay, so
Okay,
too much,
go
too
on,
much,
Naruto. Yeah.
too much alpha. But like basically, we are unification layer. The idea here is that we have three major products, and the first one being Avail DA. So data availability is like one of the most important things right now for the rollups, and we are trying to solve this bottleneck issue, right? And the whole thing with Avail DA is number one, it is a validity proof based DA as compared to like other companies or organizations. And at the same time, we also use like KZG commitments for like faster or like irrefutable source of truth. So that makes it like a better suited product as compared to like other ones. So that's one. Then we have Avail Nexus and Avail Fusion. I think QEDK should take Avail Nexus because he's like working on that, and then Avail Fusion, QEDK you can take as well.
Yeah, for sure. So, I mean, I'll just put it simply. Avail is meant to be the unification layer for Web3. And what we mean by the unification layer, of course, is basically a platform that kind of solves the various fragmentation issues that we face in crypto today. Stuff like you have your USD on optimism, but you want to spend USDT on, let's say, base, right? How are you going to do that? And our solution to that, as we're positing, is basically going to be Avail DA along with Avail Nexus, right? So what that basically means is that rollups that leverage the scalable blob space that is offered by Avail DA can also choose to opt in to a protocol or a form of layer that we're calling Avail Nexus, and they can have almost seamless interop between themselves. We are going to make use of cutting edge recursive proofs to make it happen. At least that's what we're planning for now. Of course, like all of this is subject to change, but the way that it will work eventually in the end game is that a user typically doesn't need to care about what chain they're using when they're bridging or they're transferring. Like it just works for them, and that's sort of what we want to enable, right? That's sort of the future that we envision. And of course, as we build out this Avail Nexus a product, as well as the protocol as a whole, we kind of need to think about how do we bolster the economic security of Nexus and the Avail D, right? Because Avail D, of course, has its own crypto economic security that is derived from holding Avail tokens and then staking Avail tokens as a form of crypto economic security. And Fusion will further enhance this by allowing other assets to be staked and restaked as well. That's sort of what we want to offer in the long term. And then we kind of can reuse that crypto economic security for Nexus, which means that the more security that goes into Avail Fusion, the more secure our blob space also becomes.
Got it. Got it. Cool. So, I mean, you guys um, obviously are working on a lot of things. Um, how do you do your outreach to like developers? Like, what do you like if me as a developer coming in to learn about Avail? Um, what would you expect from like builders on the platform? Like, what are the use cases that you see are going to be like really like exciting that Avail is going to enable for folks?
Hmm. So I think like a lot of like different chains, for example, like any L2, they expect their users to come and build some kind of dApps, socialify apps, and like all these things. What we are a lot more focused right now is chains themselves, like L2 chains. And the idea is like, they they basically use the Avail-DA, and then we unify their whole liquidity and the UX fragmentation, right? So a lot of these examples are basically anything that you build with OP Stack or Arbitrum, or you build any kind of Validium, or I think any sovereign rollups, right? So those are like the major things that devs come in and can work on. We also have like few things with RIS0, SV1 for verifiability and all those things. I think QEDK worked on Vector X, which he can go on for as long as you want. But yeah, like those are like the major things. QEDK, over to you.
Yeah, for sure. I mean, for me, primarily, like a lot of my work is not with outreach, but the events that I attend, I try to kind of make time and specifically talk to devs who are trying to figure out what Avail is. Because I'm not gonna lie, like the modular space as we know, it's very non-trivial for beginners to understand, right? Like, for example, like the concept of blob space as a whole, right? Like, why should like a beginner EVM developer care about blob space? Or even care about understanding what blob space is, right? So a lot of the work that we have been doing at Avail has to kind of further the understanding of data availability as a whole, or more specifically, why is data availability needed, right? Because like you have concepts like DACs, you have concepts like DLRs, and modularity for a long time. And this is something that has probably been thought out early 2017, early 2018, right? So it's not like these are like new concepts. Like, for example, if you think about Avail, the first idea about Avail was probably envisioned back in 2018 at a Polygon offsite, right? Like that's kind of how it all started. That's when Anurag and Prabal decided to like kind of pitchfork this and then get at it, right? It's just that we are finally in 24, we are realizing the need of data availability and the need of blob space. Because if you look at chains like ZK Sync, if you look at chains like Arbitrum, or if you look at chains like Base, right? You're kind of seeing the massive surge of usage that they're observing, and in terms of scalability, data availability is one of the highest bottlenecks there. Like there are other platforms that are kind of they are focused on working on consensus. They're focused on parallelization, right? DA is one of those spaces that where we have kind of been building up for a long time. So we feel that we're also poised to excel in this in a manner where like people who are using Avail, they don't even need to know that you're using Avail. So tomorrow, hypothetically, it could happen that there is a platform that is like, let's say we have a DApp like Aave, right? Aave wants to spin up a chain. They can use CDK Validium. They can use Hyperchain Validium. And to them, the user would technically never even know that they're on Avail, but it would just seamlessly work for them. And like all of the burden kind of just goes to the developers, who kind of just have like a one-time learning cost. But again, like the amount of scalability that they get in return is sort of unparalleled. That's sort of why we're building Avail at all.
Got it. Got it. Cool. So piggybacking a little bit off of one thing you said. So you said that one thing is like really trying to get people to understand, I guess, like what the need for data availability layer is. Like, give me a quick elevator pitch, like just a couple sentences. Why does the data availability? Why does DA matter? Why do we need it? Why do we need the solution?
So
Uh,
the biggest, yeah, Naruto, you can take it. Yeah.
No, go for it. I think I was just gonna say like the biggest challenge is the whole integrity and the security of blockchain, and at the same time like the bottleneck for all the transactions and the cost for L2s. These things are like the bigger issues right now. I think I saw some kind of stats where some L2 made like a revenue of like I think 15 million or something, and then they paid like 9 million or so just in the transact data fee. So something like that. But yeah, QDK, go on. Sorry.
Yeah, I was just gonna say, like, if tomorrow, again, like this is kind of me purposely making it a hypothetical, but let's say if tomorrow your optimistic rollup sequencer did decide to um, censor your exit transactions and there were no DA challenges, there is no way for you to exit because the sequencer can just hide the transactions forever, and then you would never have the required fraud proof to exit. So that is kind of uh, what data availability will solve, because assuming that all your data is posted on and attested to, there is no concept of data hiding. It's virtually impossible for a scenario where there is a ZK proof saying that the Avail validators have attested to something, and then the sequencer being able to hide it. That is sort of I mean, that's not an elevator pitch, but that is a scenario that is basically preventable by having completely transparent data attestation, right? And of course, if we go with the problem of data availability itself, basically, if let's say you take rollups today, the majority of their cost is basically being paid to L1 for data availability. Of course, with the EPI 4844, that cost has come down a lot, but the primary fact remains that Ethereum is not a DA layer. Ethereum is sort of designed to be an execution layer, which means that depending on the purpose that you're using it for, it will probably never be right. So in the future, when you kind of think of constructs like sovereign rollups, right? Sovereign rollups can have off-chain DA leveraging Avail, and then using light clients, they can trustlessly verify that the state of the rollup is always correct, which means that there is no concept of L1s, there is no concept of L2s. The rollup just keeps running. And what that means is you as a user can use the sovereign rollup, and you can have a light client running on your phone, and then you have just verified that your transaction is correct. You don't need to rely on any other form of security. And that is sort of the big end game that we kind of see happening. Um, and we kind of see more and more dApps will move towards that sort of a model in the future as well.
Nice. Awesome. Cool. So the next part of the stream, I usually go into, doing something practical with like whatever tech we're like learning about. So can you tell us a little bit about what we're going to be trying to do, and like why it's important, why people should care?
Yeah, I think we can pull up. I think it's a good idea to run a light client first, so that we can show it to people on, what it looks like. Or maybe before that, we can also look at the Explorers page, because that's one of the most important things if you want to interact directly to Avail. So that's one thing. I think I've sent you the link, Rahat, so you can probably share that, like if you do it like a screen sharing, and then we can like tell people on, like, how these accounts are, and then how to use sub wallet or anything else.
Okay, so we're live now with the screen share. I am on the Avail Explorer at the moment. So
Yeah,
when I was looking around, it
maybe,
looks like there's two networks, right, for Avail. There's like two different test networks.
yeah, right now we have Turing and Goldberg. Goldberg is deprecated, so we recommend everyone is on the Turing testnet.
Got
But yeah, just for lols, maybe you wanna open the first, the right where your cursor is. Maybe you wanna click that, and we can show what exactly does data extrinsic look like. Yeah. Can you click on data availability or data submitted? The drop down
it.
in the extrinsics, it's right below that.
Sorry.
If you go down extrinsic, right? So there's a data availability submitted
Okay.
Yeah, and then on the right, you can see data availability or data submitted.
Submit data.
on the right. On the right. Yeah, this
Yeah,
one.
that one.
Okay.
Perfect. Yeah. So this is technically what a blob that is submitted to Avail really looks like. Like for example, Avail as a DLR, there is no inference on the kind of data that is submitted, which basically means that the data that you send as a blob, it just gets stored as a blob, technically converted to something called the data hash, as you're seeing,
Mhm.
and then just stored on Avail forever, right? Of course, like the actual data might not be stored forever, but let's say if you're running an archive node, then it will be stored forever. But I mean, technically, the way Avail is going to work is at least for some time, all the data is going to be stored. And basically, the reason that we have a structure like this, where you're submitting data as a blob, is because when you have this data, we can then attest to it on other chains, kind of proving that the data was actually posted to Avail, right? So we have internal structures as well. By that, of course, I mean our KZG commitments, where technically a commitment is generated every block, and then it is verified by every other validator, and then it gets included in the block. And with this KZG commitment, we can kind of verify that the data that we have submitted, the entire data is actually there, and that the entire data is correct, right? And then you can kind of perform opening checks on that particular commitment where you can kind of verify, you can generate a proof for a particular opening, and then you can run it, and then you can know for sure up till a certain confidence that the actual data that someone is claiming, which is probably going to be like an RPC provider or a light plan that you're running, is actually there. And this is, of course, cryptographically secured. That's sort of what makes this entire model work.
Got it. Okay, cool. So this data hash could be anything. It could be, so you mentioned before, like you could, let's say I wanted to do, I'm on Optimism. I want to do some transfer of USDT on some other chain or whatever. All of this like gets hashed into a single the single data hash, and that's representative of whatever data of transaction that you just did, right?
Exactly. And if you want the, like, technically the attestation happens on the commitment as a whole.
Okay.
Technically it's a commitment of a commitment structure, so there's multiple layers.
Okay.
But what that basically means is once the attestation happens on the base layer, you can know for sure that the pre-image of the data, which is basically going to the transaction data, including your whatever transaction that you sent, is actually there on Avail. And that's sort of what we can guarantee from the entire structure, yes.
So this is just the attestation, is that correct?
This is a commitment over the data. It's like just a simple hash of the blob that is submitted.
Okay.
And so basically, like if you request an archive node or you request the entire block, you can actually view the actual data as well, which you can see on the left, the data bytes field that you see. On the left, yeah. So that is the actual entire blob that was submitted.
Cool. Interesting. Okay.
It's a feature, yeah.
Yeah, it's a feature.
It's a feature.
Yeah, you can't see it anymore. It's gone, yeah.
Cool. Does the data or the blob stay forever, or does it get deleted at some
So
point?
the blob is retained forever by archive nodes.
Okay.
Basically, it's similar to Ethereum, sort of where you can decide how long you want to retain block data. So typically, archive nodes will have the data forever, similar to Ethereum, and other nodes can prune the data as they want to. But Avail, at least in the initial stages, will have all data being stored in full nodes as well.
Gotcha. Cool. Awesome. Anything else we should know on this page specifically?
I think block details are fine. Maybe like just look on accounts if someone like wants to start the account, on how they can do it. Like you already have one, but if people need to know, just go on the account and create one. This is basically coming from like Polkadot Explorer. I think this is the fork of that, right, Kyudeka?
Yeah, correct.
But people
You
can
can just click on plus account.
the plus account on the account there. Not the other side on the right side. There's account. Right. More right. Yeah, see, yeah. So people can just like build or like get any kind of account, like make an account, and then they can take the seed phrase and then import it to sub wallet or like other wallets that are our partners. So you can literally just have like an extension with this mnemonic or the seed
Nice.
phrase.
For anyone trying to steal the seed phrase, there's nothing in this wallet.
There's nothing in the wallet, but yeah,
I just got free Avail. Thanks, Rahat.
yeah, please remove it. I don't want people to be like looking at it, honestly.
Cool. Okay. Awesome. Great. So do we want to go ahead and do the running of the client light node now?
Light client. Yes.
Let's do VLC.
Okay. Is that the curl command that you sent me before?
Yes.
Yep. That's the
Okay.
one.
All right. So pull up my terminal, zoom in a little bit more so people can see. Okay. So this is just like straight from your docs, right? Just drop that in
Yep.
there. So
Yep.
what exactly is happening right now when I run this?
So right now, what's happening is we have our light client binary. So we have a script called Avail-up. Avail-up fetches the latest script, sets up your configuration, creates your identity stuff, a proper configuration for to use, and using that particular configuration, it starts the light client for you. And what you're seeing, bootstrap done, and then it says waiting for first find as header, and then you see the first header number. That basically means like you're done. Your client is working, and
Right.
that's pretty much it. You have a working light client
Yep.
within
What?
3 seconds, right?
So
That's sort of what we have.
That's dope.
So maybe I should maybe let me explain you this. I think one thing probably a lot of people don't understand is that light clients are different from full nodes, at least in Avail.
Right.
The idea with the light clients is like you can interact with the Avail DA without like requiring like your full node or like archive node. And we have a light client network which basically gets the I think block headers like just for that, so that we can do like data availability sampling. That's another thing or another feature you can say of Avail, why we get like the data so fast. Um, Correct me if I'm wrong, QDK, or like add something to it if you want. But like that's the basic idea of light client. You don't need to like get the whole full node running and everything.
Nope, you're right. So basically, the entire intention of having a light client is that you don't need to trust Avail RPC nodes, or you don't need to trust
Yep.
any Avail full nodes or any other RPC providers, right? You can kind of have light clients communicating between themselves. So basically, they have their own P2P mesh layer where they are going to ask each other for cells, and they're going to fill up the cells, and then they're going to verify with the proofs whether it's actually correct or not. And then you can know up till a certain confidence that the data is actually there. That's sort of the big feature that we offer. And that this basically what it kind of boils down to is that the more light clients there are, the more scalable Avail becomes, because then you just need to trust um, the light client code and nothing else. And of course, like you have to trust code at some point. So this kind of makes it particularly trustless, because it's like not an entity controlled by me or you. It's basically just going to be someone else in Antarctica running a node.
Got it.
I'm
Cool.
hoping they run our nodes, yes.
Got it. So if I'm understanding correctly, the light client is really just for interacting. So now you don't have to grab a RPC node or anything like that. You're running this yourself. You can interact with Avail using the light client. It doesn't give you the full like archival data, but just enough to like start doing the interactions. Correct?
Correct, yes. I mean, it depends. So like there are different modes the light client, so it depends on that. But yeah, like let's say if you want to send transactions, if you want to submit data, some of the LC API is kind of being rewritten as well. So it's going to become much more featureful as you kind of go forward. But in this version of things, for example, you can kind of get blocks, headers. You can know, you can submit transactions. By that, of course, I mean blob transactions. Um, and basically, ideally, what would happen is you can have like roll up nodes that interop with light clients, right? And then the roll up nodes can kind of trustlessly verify that the data is there. And then you as a roll up user can do the same.
Okay. Got it. Cool. So I errored out. Is there anything I should do here? Or
I think that's probably because the RPC has too much load. Yeah,
okay,
I think that's pretty much the reason. Yeah.
gotcha. Cool. So what's the next steps? What are we going over now?
Creating the application key and post some data
Cool.
in true Avail style.
Yeah, we can go through the Avail.js idea. I just shared the link again, and
The Explorer is better, I think.
Okay, yeah, the Explorer is better actually. Yeah,
Yeah,
instead of like going
you
to
can go into developer, extrinsics, yeah, and then you can go submit the following extrinsic, and then you can go into data availability.
Yeah, this one. Uh, Submit the following
Submit the
extrinsic system. So there's a drop down.
no on the
Yeah,
yeah
here.
that
Yeah,
one,
So
and you
then
can
you
scroll up to
data
data
availability.
availability.
okay.
Yes, and then you already had create application key.
Yeah.
So this is basically, so in Avail there is a concept of namespacing. So it's basically just a way of separating your rollups data from, let's say, rollup access data, or optimism's data or basis data. So this is basically you providing a key, and then based on that key you will get a unique app ID. So you can just put any random bytes in here, and then you can kind of create the app ID, and then we'll use that app ID to submit some data.
Okay. So we just
Can you check if the account was set using the selected account? Yeah.
Yeah.
Now you can submit the transaction, sign and submit. Approve.
okay.
And then we're just going to wait for this transaction to go through.
This is always the fun part.
Yeah, it
Yeah.
takes like 2 seconds or probably a little bit more.
Cool. How would I view details about this transaction?
So you can go into network and then Explorer.
Sure.
And then you will see application key created on the right. You can just click on that event.
Yep.
Okay.
Yeah, so you can see you have got an ID there. That's your app ID 48.
So you can access everything with that 48 number. Like whenever you need to interact with your app ID, just you need to use
So
48.
you can basically run the Lite client in app ID mode, and you can specify the app ID 48, and then your Lite client will basically get all the data for app ID 48, and you don't need to worry about any other random blobs being submitted by any other chain.
Okay. So what exactly have I created here? So this application, this has an application key, all this. What do I do with this specific thing that I've just done?
So now with your app ID, you can basically submit your blob, which will now be namespaced with that particular app ID. So you can go back into developer, extrinsics, data availability, and submit data. Yeah. And then submit any random, whatever data you want to submit here. Well, those are facts. Submit transaction. And then in this app ID, you put 48, which was the app ID that you just created.
Right.
Sign and submit. And then let's just wait for it to get included.
I just realized, I think the Protocol Explorer logo blocks this little thing
Oh,
here.
yeah.
Yeah.
That's
So
okay.
now you can go back to the Explorer page. Network Explorer.
Network
Yeah.
Explorer.
And then you can click on the top event.
Yep.
And you can see that your data was created. Actually, can you click on the link on the top right?
That's right. Yeah.
Yeah. So you can just expand the left and the right. on your first event, the data ability or submit data. So you can see now to a stop your KOL, this is from the blog data, and then on the event, you'll see the data hash.
Gotcha.
One day soon on the thread guy level, you know.
One day soon.
One day, yeah.
I'm gonna need to do this again once you guys hit mainnet. Make sure this
For
lives
sure.
forever.
Oh yeah, this should stay forever, so we
We'll
should
put
do it.
this in the Genesis block, of course.
Yes.
Oh, that would be nice. Yeah, like we were asked what should we put for that. So like I think this is a good
This
thing.
is it. This
Yep.
is it.
I'm gonna just run it by leadership team.
Cool.
I'm just gonna put Rahat's photo with a kurta in the Genesis block.
Okay, so I think another thing what we can show if we have like 2 minutes is just a basic example of what we did on the code. We don't need to code it out, but like, you know, the link that we shared
Yeah.
so that people or the devs can know how it actually looks on the JavaScript side. We support pretty much, I think, JavaScript, Go, and Rust as well.
Mhm.
So,
Yes.
you know, like people can use whatever language they want to use, but if people are, you know, like more used to TypeScript or JavaScript, that's the one thing that I think I shared with you.
Cool. So I've got these two here that you sent me earlier.
Yep.
So what are we looking at?
So the basic thing for the first is if you can you click on the examples link on the GitHub, like Avail.js examples. Yeah. So the first thing you need to do is, you know, if you go down, you need to install the dependencies, which are basically, you know, TS node, and then you also need to install something called Avail.js SDK. I think it's gonna be somewhere on the Avail.js repo. If you go on the Avail.js repo, like one directory up, I think it tells you here to like install
Yeah.
a JS SDK. So this is basically a wrapper of Polka.js SDK, Polka.js SDK, and it's pretty much most of the things are same. Some things have changed depending on Avail, right? And then now we don't need to like go through the whole process of installing and telling, but we can just walk through the code for people to understand. So, for example, if you go in the node examples again, up so there's a node examples, and then node example. So here, source. So here we have like multiple things that we already gave you. Like these are the examples where people can like, you know, copy paste or like learn from on how things work. I think the easiest one would be the data submit, which I think data availability, data submission down. Just yeah, this one. So I think this is like the easiest one that people can, you know, think of or like can work with. There's also Connect, which is slightly more easier. But just for the sake of everything, we can just, you know, look through the code and see what it does.
So this is the code that was running when we just did what we did.
Yeah.
Okay.
So this is the code that is running, and what it basically does is like it takes your seed, you know, and then all it's doing is like it's, you know, waiting for the text result, looks for the taxation, and then sends one transaction for the same thing. Nothing like, you know, very hard. It creates an application. So, for example, line 22, that's the one which, you know, creates the create application key, then sign and send. That's the like, one of the main lines. And QEDK, like I know you know better than me, so feel free to correct me if I ever say something wrong.
I don't know what I'm talking about, bro. Don't worry.
I thought
Yeah,
you built this.
we worked here and there, you know, we worked here and there. So yeah, that's the basic like most important line is not 22, sorry, 23. I think yeah, 24 because you have a different yeah. This is the most important one where it just uses the data availability dot submit data and then it signs and sends it. And then you know this makes the whole transaction call that we did on the Explorer side. The only difference is we didn't code it out. We used our Explorer, which like devs can go through and like learn on how it's going. But if someone needs to code, someone is working on the chain, these are the examples, and we have written the examples so people can like look at them, and then if they want to run, they just need to like run npm run data submission, and it runs the whole thing for them.
Got it.
But like
Cool.
this, for example, in this, we are just submitting the data hello world. You can change it to anything, and it will send the same thing. It will do the same thing that we did from the Explorer side.
Cool. So the interaction that we did earlier in this code is kind of like you're interacting directly with Avail, right? So
Mhm.
I remember at some like previous like hackathons and stuff, you guys had like I think there was this thing where it was like an OP roll up using Avail, right? So in a case like that, like what would be the difference in like the interaction if you're using like a chain with Avail versus using Avail directly? Are you still using like an example like this, or would it just default to kind of like how you would normally interact with the chain?
So for this one, I was waiting. I was thinking if you would want to answer this, but for this, what we're doing is we're just interacting with the Avail directly,
Right.
Avail DA. But if you wanna like use OP, then we have like OP stack adapter, which people generally use. QDK, I think there's like a whole thing where people can post to the OP adapter, right, or OP Explorer.
So, okay. So the thing is, like, these scripts are only for like testing, right?
Hmm.
Because there is no
Yeah.
reason for like a random user to
Right.
just come in and post data, right? So these are basically examples for, let's say, you are a roll up dev.
Mm.
Actually, you are. I can use you as an example. If you were building on a VLDA, this is what you'd use to learn. But technically, all of this thing that you're seeing, depending on the language that your rollup node is in, it would
Mhm.
internally just do all of it, and then it would take in the particular commitments. It would generate the proofs, and it would kind of verify the proofs as well. So like the end user virtually doesn't need to care about the DA layer. Is sort of the goal that we're building with,
Makes sense now. Okay. That clears it up in my head. Thank you for that.
for sure.
Cool. Did we want to look at the other one too? I think no, or this one was the same thing. There was another one you had sent me, right?
The
Data
other one,
submission.
yeah. We were looking at the data submission,
Yeah.
and I think we sent create application key.
Okay.
That one, yeah.
Okay. So this was the original interaction I did when I created the key.
Yes.
Okay.
Exactly. Yes. So this is
And
basically the same thing as what you did on the Explorer a
Explorer
couple of
side.
minutes ago. Like virtually the same thing. I think the only the configuration is different.
Okay.
But yeah, the idea is that every rollup will have their own app ID, and there will be a world where hypothetically we can have like 10,000 of the sovereign rollups, all with their own app IDs, and they're kind of all relying on these light clients that are indexing just their data. So it's like virtually, I mean, I don't want to say zero cost, but it would be much, much cheaper than having a base layer, or like actually having Ethereum as a base layer. But yeah.
Makes sense. Cool. Awesome, guys. Is there anything else that we want to go over or take a look at, touch on, code wise?
I think I just want to highlight the fact that we also have examples in Rust and Go. So you can go into Avail, um, yeah, the top level examples, and then Go examples.
Okay.
Yeah, and then we have Go examples here. Dino is also TS stuff, so I don't want to show that again. But let's say, like a lot of the nodes that we have, roll up nodes, for example, for CDK, ZK, VM, they're kind of written in Go.
Mhm.
So we have a branch of GSRPC. It's basically a substrate RPC client written in Go, GSRPC, that we have adapted for Avail. These are basically the examples for that. So if let's say you have a rollup node in Go, you can kind of leverage GSRPC to do exactly the stuff that we showed you in TypeScript. So the lift is virtually similar, and you don't need to really worry about kind of building something particularly. It's something that we already provide basically.
Got it. Cool. So you guys do Go, Rust, and TS.
TypeScript, yeah.
Yeah.
TS,
Cool.
JS, of course, yeah.
JS, yeah. Awesome. Dope. Well, thank you guys for taking me through all of that. Before we wrap up, any other call outs, anything that folks should look at if they're interested in like starting to play around with any of this? They want to get in touch with you all. What's the best way to do that?
I think Twitter is the best thing. We're so much active that we see all our DMs. Telegram is the same name as our Twitter account. So those are like the best ways to reach out to us. QDK, you have some final thoughts?
Yeah, for sure. Feel free to reach out to me on Twitter, reach out to Naruto, up to you. I just want to give one call out to our careers page. We are actively hiring for BD roles, for DevOps roles as well. And of course, like if you are a good engineer and you have confidence, just apply with any role. And if you're good enough, we'll take you. So yeah, we're actively hiring. Just another shout out, and that's pretty much it for me.
Yeah, if you end up working with us and you apply through us, so me and QDK gets a good bonus and we take like 20% of salary. That's like a condition, but decide for yourself.
Yeah, for this podcast, we're giving a 10% off. So we'll take
10%
only.
That's a steal. 10% off. Nice.
Yeah, so
I'll
5%
apply,
each,
applying right now.
and maybe we'll
Use the
take
code
some from
Protocol
Token L.
Explorer.
Yes, use the code Protocol Explorer with an X.
So you heard it here. Use the code Protocol Explorer to get 10% off of your salary.
Yep, exactly.
Best deal ever, yeah.
Awesome, guys. It looks like there's I think you guys had sent me like a blog post to share as well. Any comments on that?
Yeah, that's our latest Road to Mainnet blog post. Just want to update the community on where we are at Mainnet. And of course, I just want to say and emphasize it's going to be very soon.
Nice. Cool. Awesome, guys. Well, thank you for hopping on. If you have any last thoughts, let me know. But it was awesome to have you both on. I learned quite a little bit about Avail, and hopefully folks also tuned in and learned some stuff too.
For sure. It was nice having
Thank you so much for
talking to you
hosting
guys.
us, Rahat.
Yeah.
Yes, sir.
I think we moved this around quite a bit, but I'm glad we were able to get this in now.
Yeah, we
well,
delayed
we
like
got
for
it.
4 weeks.
My bad, guys.
Yeah, it was mainly QTK's fault.
Okay. Now you'll sell me out, yeah.
We have to throw somebody under the bus.
That's true.
And like I think we've been mean enough to Naruto for most of this.
Yep. Sure.
Yeah, I mean, he's the big KOL. He gets it.
I'm still learning.
All right, y'all. Thank you so much for tuning in. The next episode of Protocol Explorer will be announced very soon. We're still deciding on a couple things there, but stay tuned and make sure if you want to get the latest updates, join our Telegram group. You also have access to some of the people like Naruto in that chat. So if you ever wanted to bother him in a group chat with a bunch of other people, you can do that too.
Cool. All
Let
right,
me
guys.
just hop in real quick.
I had to just show this real quick before we left.
There is no midnight. I love you.
There is none. Cool, guys. Thank you so much. And hopefully we see you in another episode.
Likewise. Thanks, Rahat. Thanks, Naruto.
Cool.
close the stream.